Hi everybody, my name is Mutwana, or you can call me Hamish or Mutwana Kosi. Let's get started. So look, before I get started, right, let's just read some few comments here from some of the students. You know, they always send me comments, say, hey, this is the face. This man is the first time I actually get these comments from Brazil. Hey Mutwana, I'm from Rio. Oh man, thanks a lot, man. That's so beautiful, man. I want to say hello, man. I like your video. I've been watching. I'm from Brazil, Rio, but I live in Manchester, United Kingdom. But you know, I discovered your channel while I was in Brazil. Man, that's so beautiful, man. You know, my name is Tatiana. Oh man, that's beautiful, man. Tatiana. Okay, from Brazil. That's Tatiana from Brazil. And also another comment coming from brother here. He said, yo, Mutwana, how you doing? I'm doing my eye level and thanks a lot. You help me a lot. I'm from India, but I live in, man, why everybody live in UK till they send me comments? He from India, but he live in UK. Let's live on let's put in the comments here. Man, my brother, man, from South Africa, that was sending me question here. My brother from KwaZulu-Natal. Say, yo, Mutwana, so born, how you doing? Man, that's so beautiful. And the sister here, man, let's see some comment from the sisters Bongile. She said, yo, Mutwana, how you doing? You know, I appreciate for, you know, the love and support. You know, you make me proud. You know, I've been following you from the beginning. Thanks a lot, Bongile, I appreciate. Let's see this one. Say, hey, my name is Sisi Bongi from Eastern Cape. Mutwana, you're doing great. And, you know, come on now. Really, you going to do this? Please swear, I'm not going to say here. And she sent me a lot of kisses here. But come on, this has nothing to do with this. But I know they show me love, you know. Thanks a lot, I appreciate that. So we can read all the comments. So just to let you know, that's some of the comments from the students. So we have a question right here. They say, solve this question, integrate. So nobody going to tell you which method you're going to use now. It's up to you. So I'm going to say the first question is easy. Let's get started. So face outlet, that one. So I'm going to say integral. So I got my x, and here's going to be, that's going to be 7 squared plus x squared. I'll put that as an x squared in the bracket square dx. And then I'll let, let's say u equal to x squared. Differentiate this is going to give us the u. This is going to be 2x dx. So you see this x dx. So divided by 2, this in this cancel. So x dx equal to du over 2. So I want to say integral x dx equal to du over 2. But this 2 will take it to the back. See what I'm saying? And this is going to be 1 over 7 squared plus x squared means equal to u. So this let me say u squared. So this is a tan inverse of integration. So we're going to say, look, let me take it back a little bit just in case if you don't know, you forgot. See this one? This is a tan inverse. Or you call it arctan of integration. So I can simply just go straight and just put it in and get our answer. So this let me say 1 over 2. Okay, tan inverse, what you do, just say 1 over your a. A is this number here. Let me just take it back a little. If somebody gave you, let's say this is a squared plus f of x squared dx. Whenever you have this format here, then just know this is tan inverse of integration. So let me say 1 over your a, and then differentiate f prime, and then you say arctan, and then write your f of x alone over your a with no square plus c. So we're going to do the same thing here. So 1 over a. A is this number with no square. Multiply, differentiate that one. You differentiate u, you get to 1. And this could be arctan. If you don't want to say arctan, you can simply say tan inverse of f of x. F of x is this one here. U. But for now, f of x is u. So u over our number, which is 7 for this case. And then you plus our, for now, we're going to plus our c later when you substitute it back. So simply we're going to say, we know the value for u. U equal to x squared. So I'm going to replace this with the x squared. Okay, so we're going to place that with the x squared. So then it's going to become 1 over 1 times, it's going to be 14. And this is going to be tan inverse. If you don't write tan inverse, you can say arctan. Either of the two is acceptable. U equal to 2x, equal to x squared, my apology. X squared over 7, the plus our constant c. That's how you do. So even question 4 and 5 is the same methodology. So let me just do 4 and 5, and they'll go back and finish 2 and 3. So we're going to play the same game for 4 and 5, correct? So you should now apply this question. It's very, very easy, okay? Now let's do question 4 and 5. So since it's plus, and I can break that one to square, and then it's easy, it's finishing now. So there's going to be 1, and this going to be 3 square. 4x means it's going to be 2x, bracket square, and then dx. So let's play the same game. So then I'm going to say this and say this is equal to 1 over. Now 1 over your a, which is 3 with no square, and then differentiate 2x, which is going to give you 2, and then arctan, or if you don't want to say arctan, you can say tan inverse of whatever you have, fx, what is it, fx 2x over a equal to 3, and then you plus c. We plus c because we don't have no limits. But if you have a limit, do not plus c. Means if, let's say you have a 0 to 1, means here you're going to start 0 lower limit to 1, and then you substitute upper limit minus lower limit, means it's going to be 1 over 6. What is the upper limit? 1. So I was going to say arctan of what? Of 1, and then we minus, now for lower limit, because you must take upper limit and then you substitute by lower limit. So you say arctan again, and then you put in lower limit, and then you push in the calculator, you get your value. If they give a limit, that's how you do. But since they didn't give us limit, it means you don't want to introduce anything which was not given in the question. So you follow how you ordered in mathematics. It's a set of rules, so you follow the rules. Okay, now let's do the last one. So you see the last one here, they're giving a tricky way. It's very easy, but they're giving tricky way because they want to see how you can come out with that square. Look, so they give you inner group. Look, let me tell you something. If somebody says 7, and if somebody says 7 square root 7, it's the same thing, because 7, if you square root and then square, is going to give you 7 still, because this and this is going to cancel. So now I'm going to play that game here. Okay, I'll play that game. Look how I'm going to do. I'll say these 5, since if I want to get the inverse of 10, I need to have a square of a number. So I don't have the number. So I'll say this is the same as 5. I'll square it and I'll square. It means it's still 5, but now it's in a root format. And this can be 4x square. And there we have our 1 and then dx. See now we're finishing? We're finishing now. So now I'm going to say it's okay, we finished. So this time I say 1 over our a. Our a is this number. Leave the bracket, and then we multiply by f derivative. When you derivate 4x, look, derivative is going to give you equal to 4. So multiply by 4, and then we're going to say add tan. If you don't want, you can say tan inverse of our f of x. What is f x? 4x. And then divide by something with no square. And then we finish. Equal to that. See what I'm saying? So then you can say 4. See, you can say, let me put 4 before root. So I can say 4. Root of 5, and then that's our answer. Now let's go to the question number 4. Number 4 is actually straightforward. Yeah, straightforward. It's actually easy. This is number 4, and then we go and you do our factor theorem in trigonometric, which is question 2 and question 1 and question 3. Okay, so this is straightforward. Probably can just give you for the homework, because you can see plus this is going to be 3 square 2x. Okay, so let me just do straight away. This is going to be 3 square, and this is going to be 2x bracket. So I'm going to say 1 over my a. A just is 3, and then differentiate 2x is going to give us 2, and then tan inverse, so you can say tan if you want. Tan of f of x means it's 2x over your number, which is 3, and then you plus your constant because there is no limit. That's why we plus the constant. Now let's go to this question. So this is the factor theorem of trigonometric. Whenever you have integral of cos or any two trig, especially cosine sine, cosine sine, cosine sine, cosine sine, those two, and then if there's a multiplication in between, see, cosine cos or cosine sine, either can be sine and sine, either of the two. See, and then you know, oh, is the factor theorem. So now how we solve factor theorem? Now we need to go back to the compound formula. You need to, most of the time I tell people, no, do not memorize. Get used to this. Understand, I never memorized this part of the factor theorem. Now let me show you now how we go about factor theorem now, because it's very, very important. You need to know the factor theorem of trigonometry for you to solve this question. Look, we know now. Let's go back to the compound phase. Before you do factor theorem, you need to do compound. If somebody give you, let's say, sine a plus b, What is that in compound? We know it's going to be sine cos, sine of A, cos of B, and then if it's plus, it's still going to be plus. What you do is switch this. You see, this is sine A cos B. Switch it. It's going to be cos A, and this is going to be sine B. From the Trigonometric formula, compound, you memorize this. We know this from the Trigonometry, but if it's minus, you do the same thing, but you leave it as minus. So it's going to be sine A cos B. And what you do, you see, the easy way to memorize, me most of the time I tell students, like, look, if it's sine compound, what you just remember, you have to remember only one thing. Sine cos. Sine cos. If it's sine plus or minus. So sine cos, and then what you do, you say, if it's plus, it's going to be plus, and then what you do, you switch this. You see, you switch this. This is going to become sine, you see. This is sine, it's going to become cos, but A is still there, A in its position, and this B is still replaced with a sine. So we're going to do the same thing here. Sine whatever, sine cos. And if this minus must be minus, then we'll switch this, you see. It's going to be cos of A and sine of B. This is only for the people who probably don't know the compound formula or they don't know how to do it. So what you do when you reach this point, what you do, look, what you do first, plus, and then after, minus. That's how you get your factor theorem. We call this factor theorem. Now, let's start with the plus, and then we're going to go to minus. If we plus these two, look, this and this is going to disappear because it's the same thing, cos A sine B. But this is plus, plus, minus, means it's going to become 0. Look, let's add this and this. It's going to be sine A plus B plus, we add under like you go down. Sine A plus B plus sine A minus B. Now we come here. This is the same thing. This plus that, so it's going to give us 2 sine A cos B. But look at this. Cos A sine B is plus. Plus minus is going to give us 0. So it's like a 0. I don't have to write that. So your intention here, make the subject to the formula this one here. So divide by 2, and then all this divide also by 2. See what I'm saying? So divided by 2 here means it's not going to be there anymore, and then divide also here by 2. Everything must be divided by 2 for this case. Like it should like this, divided by 2 this in this class, and then this is going to come here. So the compound formula, let me write that, of factor theorem, you see now, so it's like, can't you see this loop, this sine A cos B, sine A cos B, this same is there. You see what I'm saying? So that's how you know this factor theorem. But you only can get easy if you know the compound formula of the trigonometric. See, so for my case, so I'm going to show you in a situation where like cos. So let's say you have integral sine, let's say 3x, look at sine, let's say 2x. How are you going to do that? Because now you did the face on, how you going to do it. So now for this case, now let's do the face on face. So I'm going to say sine A, but what is a sine A? A is like 4x and B is like 5x. So that means if I have to interpret this, it's going to be same as the 1 over 2, 1 over 2, 1 over 2, and then I'm going to say sine A plus B. What is the A? A is like this and that. So this and this is going to give us 9x plus sine A minus B. What is the A? A is the first one. Minus 5x. So 4x minus 5x is going to give us negative x. So we're going to have a sine negative x. And then we have a dx. So the meaning of this sine A, what is A? A is like a 4x, and the cos is like 5x. So the meaning of this is equal to that. But remember, if sine is the odd function, so you can take this negative out. So this negative is going to come out here for sine, because if you have a sine of negative theta equal to negative sine theta. Excuse me, sorry. So for that case now, we're going to say, how are we going to say? We're going to say now, instead of that, I'll replace that with this stuff over here. So I can simply take, say, if I take this out and replace it with all this, but a half is going to go outside because a half is constant, and there's an inner growth, the first one, which is sine of 9x, dx minus inner growth, the second one, sine x. So now we can just simply finish up. Now, when you integrate the sine, this is going to be 1 over 2. Okay, when you integrate this, it's going to give us 9 at the bottom. See, and sine of 9x is going to give us cos negative, remember, negative cos of 9x, and this is going to give us minus. You see what I'm saying? This is going to give us, okay, minus is still here, but then we're going to have another minus going to come up, because when you integrate sine, you get negative cos. Go to your integration table, so it's going to be negative cos x, and then plus constant, because we don't have no limit. 2 times 9 equal to 18. So 1 over 18. And this is going to be negative, negative is going to be plus. So you can either start with this and then come with a negative. That's a good way of saying, oh, cos of x minus 1 over 18 cos of 9x plus c. So you see, so you just have to know your compound formula. If you know them, then it's easy. So the tricky way is just look at this, try to remember your compound formula. For example, like me, this one here, I'm going to use compound formula of cos, because compound formula of cos, let me show you now. So I'm going to say now, because I know the compound formula of cos, it has a cos. Even the last one also, I'm going to use the compound formula of cos, because the compound formula of cos, it has a sin. So just memorize your compound formula and it should be fine. It should be alright. So I'm going to say, look at this. So I know cos A plus B. What happens? It's going to give you cos of A, cos of B. If it's plus, it's going to be minus for cos. And it's going to be sin of A, sin of B. So can't you see this is a cos, sin. So meaning, for, you see, this one here. Meaning, so I'm going to say the same thing, but then you minus. Take the same thing, then you minus. So this is going to be cos of A, and this is going to be cos of B. If this minus, for compound formula, is going to become plus, sin of A, sin of B. You memorize this, family, right? I'm not doing any magic, whatever. You can memorize the formula. So what you do here, look, your intention, you want to get cos. So you're thinking, cos is somewhere here. So should I plus or minus here? Oh, I know I'm going to have to plus, so that these can go. See, but if I was looking for the last one, sin, I know I have to minus, because I don't need this, they has to go. So now for this case here, since I need cos, then I'll simply say plus. So when you plus, this is going to be cos, it's going to be cos of A plus B. Or I can simply, let me write like this, sorry. If I plus this, and this is going to give us what? Look, plus, minus, plus, it's going to be 2 cos A, cos B, because there are two of them. 2 cos A, cos B, and then equal, you take this now, you add. So cos of A plus B plus, cos of A minus B, cos of A minus B. And then what happened? Your intention, you want to get what? Cos. So what happened here? Then I'll simply say divided by 2, So I can simply divide by 2 and then divide by 2. So I can put bigger bracket. So I don't need this anymore. So cos of A, what is A? A equal to 3x. So I can say cos of 3x, cos of, what is a B? B equal to 2x. Are you with me? So B equal to 2x equal to 1 over 2 cos of A plus B. So cos of A plus B means 2 and 3 equals, it's going to give us 5x plus cos of A minus B. What is A? A equal to 3x minus 2x is going to give us x. See, so you just go how it is. And another thing, just remember, right? If somebody give you cos of negative theta, this equal to cos of positive theta. Okay? Because cos is the even function. So now, but that's not part of the function. I was just trying to, it was not part of the equation. So now I'm going to place this with this. So I'll say, simply say, I'll take a half outside here. A half is going to go out. And so I'm going to have integral of all of these equal to that. So cos of 5x dx plus integral of cos of x dx. So then the equation is finished. So then I'm going to say this is same as say 1 over 2, and then we say, okay, this is going to give us 5, and the sine of 5x, okay, plus, sine x plus constant. This and this is going to give us 10. That's how you do. So same with the last question. The last question I was going to say, look, let me show you. I wasn't going to do all the way because I was going to use the same formula here. But there was no need for me to plus. Because if you look careful at the last question, look, you want to get sine. So sine means the same formula we'll use, but then here I wasn't going to plus because, you know why? Because my intention, I want to get sine. So I need to minus here, so I have minus sine, minus plus, going to give us 2 of these. So this is going to be negative sine. Look, it's like negative sine, cosine, negative plus sine. So it's going to give us negative 2, this and this. Look, negative this minus plus. So it's going to be negative 2 sine B. Sine A, sine B equal to, and then you minus these 2. So it's a cos of A plus B minus cos of A minus B. See what I'm saying? Divide by negative 2, divide by negative 2. So it's not going to be here anymore, say? 1 over negative 2. So we know A and B. What is A and B? Our A we know. What is A? Our A equal to 3x and 2x. Oh my God. You know what? The first other question I did wrong. I just took this value instead of take another one. But I think it's the same strategy I was going to use, right? So now let's just play around with this. Let's say this 7x. Sorry about that. So this question is supposed to be like this. Because I made a mistake, you know. I was very careless. Okay. Sorry about that, but I think you understand what I meant. So now, we count for that. So if it's like this now, so we're going to say sine, what is A? A equal to 3x. Sine B, what is it B? B equal to 7x. Okay, equal to 1 over 2 negative, okay, cos A plus B means 3x plus this is going to be 10x minus cos A minus B means 3x minus 4x is going to be negative 4x. Okay, so now this, same as say this, remember, if you have a cos negative theta equal to cos of theta. Remember that, right? So this is going to be just a cos. Do not take it out. You're going to be wrong. For sine, yes, you could do that, but for cos, no. Because cos is the even function. So now we're going to say this equal to, we can just do, say, it's going to become positive. Right there. Do not take it out. No, you're going to be wrong, okay? Because cos is the even function, means it automatically, because it's negative, right? So it's like cos of negative theta, the same as a cos of theta. So it's going to automatically become positive. But you need to show you need to show in your solution, okay? So now we're going to say, now we're going to replace all of this in here. Yeah, in here, yeah, because remember we switch it. So I'm going to say, let me take negative a half outside. So we got negative a half outside. And then I'm going to say integral of the first one, cos of 10x dx, and then minus integral of cos for x dx. Okay, so now we say negative a half. Now this is going to be, my goodness. Now this is going to be 10, and this is going to be sine of 10, sine of 10x, and then we minus. Now this is going to be the same game here. Okay, but remember this negative when it comes back is going to be positive 1 over 2, and then multiplied by 4 because you differentiate that one is going to give you 4, and then this is going to give a sine of 4x plus constant. So now this is going to give us 1 over negative 20, sine of 10x plus 1 over a sine of x plus your constant. Look, I need you to tell me where you come from, okay? Please tell me where you represent. See, just like I say here in the comments, right? You tell me where you come from, and if you enjoy this video, please let me know so I know. Just like, where does student come from, man? It's from Melbourne, Australia. He always send she, actually, so I'm sorry. I say, yeah, I'm a Jessica here from Melbourne, Australia. I want to say thank you so much. You know what? I enjoy your reply to my message all the time, and I love it. Jessica, no problem. You can send me a question anytime, right? Feel free. She said, I'm doing my face here, man. My Melbourne, and I love you so much. You know, I've got a friend also. She's from Canada. You know, she's my best friend. Come on, girl. You wouldn't have to tell me all of this now. Okay, no problem. I love it. So, thanks a lot, Jessica, and your friend from Canada. You know, leave a comments. You know, you can send me question, or you can send direct me question. DM me. Okay, if you get confusion, just direct message me. Okay, and this is way easy. So I'll see you very soon, and let me know where you come from. Let me know where you represent. Thanks a lot. Peace, and peace. I'll